Hello. All right, this is question 6b of the 2013 A2 programming paper. Okay, well, not really question 6b, but rather a pre-question, if I may put it that way. So the question says the program shown below is used to read a binary file named students file.bin. Each record in the file contains one element of an array called students previously returned to the file. The elements of the array are of type student struct. Then it further goes on to say, write down what the program will display on the screen. Okay, given what is given on the question there. But before that, I want us to look at how we even write to the binary file itself. So we are going to create that file and create that array and write that array to a file. Right. So shall we continue from there? So start with a hash include standard input output dot h, and then type def struct, and our structure is an integer inside and a letter. Alright, that is all, and we're type defing and calling it student struct. Okay, alright, let's start then our main int main. Okay, now the first thing we want to do is declare an array, right? So let's declare that array student struct students, and that will be 5. So what we've simply done here is declare an array with the name students, and it has 5 elements, and they're all of type student struct, meaning that each element will have number and letter inside, right? Like what we have there. And they're all stored in different addresses, which are sequentially stored, so sequentially located in memory, right? So let's fill that up. So let's initialize our array. I'm just gonna do that. Okay, so the first element will have 0a, so it will have in number there will be 0, and then the character in the letter there will be a stored inside there, right? For the second element it would be 1 and b. For the third one it will be 2 and c. For the fourth it will be 3 and d, and then lastly we will have 4 and e. Okay, and we're done there. Okay, so now we need to open a file, but before we do that we need a pointer to type file, so that when we use fopen then it allocates to us the address of the file, right? And then we can start editing as we please. So file cf pointer, I'm just using the standard notation here. You can give it any name that you wish. Do not regard this error, it's just because I even compiled, that's why it doesn't realize that. But anyway, let's continue from there, and then cfptr, and we are opening a file using fopen, and the first argument of fopen is the file name, right? The file name, we will call it students file .bin, right? And we're opening it in the mode writing to it in binary. Okay, so let's look at what this would do, right? So fopen will open a file, students file.bain, and open it in writing mode in binary. If the file does exist, then the file will be located and everything inside the file will be deleted. However, if the file does not exist yet, then the file will be created by the function, and then we'll start writing to the file. If neither of the two can be done, then it returns null. Fopen will return null to CFPDR. The other two options, it will return the address of the location of the file, because we could open it or we could create it. Alright, but if it can't open or create a new file, then it returns null when it is under writing in binary mode. So let's proceed from there. So we first need to check though if it could even open CF. So we check using the if else statement. If CFPDR is equal to null, then we want to print out to the user that file could not be opened. Alright. Else, if the file could be opened, then we want to start doing something. Then what we will have is fwrite, and the arguments that fwrite takes, because we're writing to the file in this case, is the address of the variable in which we're taking the information from. And here I just put students, not ampersand students, just because the name of an array is the address of the first element. So this is just the same as the address. There was no need for me to use the ampersand here. Alright, so we have fwrite, and then we have the number of bytes and the size of each of the elements in which we want to store each of the structures, the 10A, 1B. How big should the memory space be for us to allocate, so that everything is written appropriately. Then we are going to say size of, because each of those structures in that array of this type, so they should all occupy the same space as what this would occupy, right? Each element should occupy the same space as what that should occupy. So therefore we have size of student struct. And how many elements are we copying? We're copying all 5 elements in that array, right? And where are we copying to? We're copying to the file. So we designate the pointer there because it has the address of the file. And then we have written to the file. And afterwards we can then say fclose cf pointer. Rather, let me put this outside. Alright, so we are done there. Let's compile that and see what we get. Okay, let's run it. In this case, we're not outputting anything, we're just taking that file and making it. And the program is run. Now, let me refresh here so that you can see the binary file. Okay, and there it pops up, students file.bin, and that is what it contains. That is the entire file at this point. We cannot read binary. This is just machine language, in other words, but all the information that we typed in is contained in there. Alright, that will be all for writing to the binary file in this case. Take care. I hope you enjoyed this and I hope it was beneficial.